Hey everyone. Now I recently changed my VPN from OpenVPN to Wireguard. And when I say VPN, I mean a real VPN of networks that I control, not this other VPN talk that you hear about. So I changed from OpenVPN to Wireguard. And the reason is I was told by a lot of people that it's smaller, it's lighter, it's faster, it's better. And it is. So I'll show you that with some graphs and stuff. But the reason I use a VPN is ultimately because I want to connect to my network from somewhere else. That's basically it. And they've also got a site-to-site setup as well that I'll show you. So I'll do this, and I'm also going to use this this tablet here and try and draw some diagrams and stuff. So it's the first time using that properly, so it might be a bit rough, but it might be all right. So I'll rip into it now. Okay, so to start with, I've got two computers, here and here. So this one is on a 192.168.10/24 subnet, and this one over here is on a different subnet, 192.168.100. So they're going to be the two machines that I'm going to set up. Okay, so I've got two machines here on different networks. I've got this one on 192.168.10/24 and the other one I've got on 192.168.100/24. So that's what I'm going to set up. So the first thing to do is install Wireguard. Just like that. Install Wireguard. Okay, so what I've got is one machine over here and another one over here. They're the two that I just showed you. And I'm going to make some files on each of these. That's the private and the public keys. Okay, because it uses the good old private public key type of setup. Okay, so I'll just make some notes here. Okay, so what I'm going to have over here is a private key and a public key. So I'm just going to generate those. Private, public, and it's going to be the same, well, not the same keys, but I'm going to do the same thing over here. So private and public keys. So I'll do that now. So firstly here, I'll go to the etc Wireguard directory and generate the key. Now I've got to do this umask 077 to make the permissions what I want them to be, so it's only readable by that user. So do wg.genkey. If I just do that, it'll just show you the output. So just do it a bunch of times, it just shows you it generates it. But what I want to do is generate that and put it into a file called private key. So that's it there. Private key, boom. And what I want to do now is create a public key from that private key. So instead of just printing that to the screen, I'm going to pipe that to wg again, create a pub key, and I'm going to put, if I just do that, it'll just show you the public key. What I want to do is send that to a file called public.key. So now I've got two files. I've got the private key, which stays here, and the public key that I give out to the other side. So I'll just do that on the other one. Private, pipe that to the pub key, public.key. So that's the same sort of thing. So now I've got those files on there. They're just kind of kept on the computers. What I want to do is make a config file. So these hosts will have a WG0 adapter, both of them. WG0, and that name comes from the config file that I'm going to make called wg0.conf. So they're both going to have a wg0.conf file, and in them the private key is going to be here for this one, so it's going to be the private key, and the public key is going over to the other side. So this public key, public. Meanwhile over here, this is going to use its own private key, private, and that public key is going to go over here, so public. So they're going to form part of the config file. So in my setup here, I'm going to call this one the server, and this one the client. So this will be listening for connections from here. You can have both being a server, basically listening on a port, so connection can come from either direction, but I just stick to a server client sort of setup. So there's going to be a port that this listens to over here, which will be 51820, and I'll use that for the client to connect to. Now the other thing to think about is what network address these are going to use. So what I'm going to use is 192.168, something I'm not using, so 200. I'll call this 1.1 and this 1.2 just for now. 168.200.2. So I'll fucking keep it super simple. I'll make that /24. So when I get that connected up, there'll be this VPN network between them, which is only really going to have those two hosts on it. That'll be the 192.168.200.0/24 network. So if other clients join this in future, they'll also be part of that network. So I'll make the config for the server first. Right, so on the server, wg0.conf. So you've got interface. So this is the IP address of it, like I said. And address equals 192.168.200.1/32, just to say it's a host interface. Next is the listen port, equals 518.20. Now comes the private key. So I'll just get out of that. Those keys that I made, one of them's the private one. Don't point to the file, you've actually got to copy the key. So private key equals that. So that's kind of it from the server part of it, but now I have to tell it what peers are allowed to connect to it. So for the peer, I have to put the public key. So this client is going to be the peer for this server. So I have to get that public key, the client's public key, over to here, that blue one. So I'll do that now. So what I'll do is I'll just go to that client machine. So they're the two files, but I'll just put them into the Wireguard directory. Okay, so the public key is what I want to put over onto the server. So I'll put that as the public key over here. Okay, so that's the peer's public key. Now the allowed IPs. Here's where I want to put the IP address of what the client's going to get. 192.168.200.2 and just that host. That'll do for now. That's very basic, but that's all there is for the server setup. On the client side, 0.conf. It's very similar. First I have to set up the interface with an address 192.168.200.2 and its private key equals, should have taken note of that. So here it's just its private key. So that's it for the interface. Now the peer that it's going to connect to is obviously the server. So I need the server's public key. So back on the server side, just grab that public key. Public key equals that. Allowed IPs equal. Now I'll just put the other end, which is 192.168.200.1. Now I have to tell it how to get to that other machine. So the endpoint is basically what its public IP address would be, which in this case it's not too public, it's 192.168.1.3, and the port number, which is 518.20. And one more thing is the persistent keep alive. I send it keep alive every 5 seconds. That way, if there's no activity from the client or the server wants to send something to it, at least there's a keep alive. So I'll keep that there. And that should be it. So on the server side, I've got a setup that looks like that, and on the client side, a setup that looks like that. So I'll start the server, wg quick up, and this wg0 is just the file name without the .conf to say which adapter. So you set that up, you can see it's added some routes there, and if you look at the links, you can see I've now got a wg adapter. And if you press wg by itself, it just shows you what's what. So that's saying that's itself, and the peer that's going to be there is going to be that one. So I'll go to the client side, wg quick up wg0, same sort of thing. So now if I show wg, you can see 14 seconds ago it did a handshake with the endpoint that we're talking about. So on the server side, it's also got the same sort of thing. So for here, I could ping 192.168.200.2, and that's the far side. And same obviously here, 192.200.1, bang, bang, bang. So that's the server just pinging that client, no worries. So if I take that down, quick down WG0, the pings stop. Start it back up, and the pings continue. So that's good. Now stop the server side as well, and I'll do a capture. I'll use a capture filter of UDP port 51820, so I don't see any excess stuff. Okay, so at the moment, neither end has WireGuard running. So what I'll do is I'll start the server up. So WG quick up WG0. So it's up and it's ready, it's listening, the routes are added. Obviously nothing happening on the capture yet. So on the client side, WG quick up WG0. We see some action here. So just make that readable. You can see what happened. So the handshake initiation came from obviously the client to the server, bang, 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 and there's keep alives. And I set them every 5 seconds. You can see 0, 5, 10, 15, there's stuff going on. So if I ping something, 192.168.200.2, what you'll see in the capture is just some data. And what you will notice is while there's data going through there, there's no keep alives because there's no need. It's already kept alive by the traffic. Stop pinging that, and when there's no traffic, 5 seconds later, there'll be a keep alive, and there it is. The keep alive obviously knows it's keep alive because there's no payload. It's just a keep alive. So that's that. So that's all good and well, but we like IPv6 around these parts. So what I'm going to do is set up an IPv6 network between those two hosts. And if you remember in IPv4, I used 192.168.200.0/24 for the network. I have to create a private IPv6 network that won't exist anywhere else in the world. And there's a method to do that. So I'll show you that now. Right, there's a whole document about this, which I read and seems pretty legit. So I'll put a link to that if I remember, so you can have a look through it. But the short version is, it's got to start with FD, and the rest up to 48 bits has to be random. So there's an online generator here, you can just generate one. So it'll always start with FD and just something random after. So I'll use that. So back in the config, my address that I'm going to use up here, I'll use that with, I'll use 1 at the end, and for the client, I'll use 2, and they're the full host, so /128. On the allowed IPs, I'll just put the other end 1. So that, I'll use 2 there, /128, just to keep it simple. And over here, same sort of thing. That with 1. And that should be it. Still got it running, so I'll just disable it at both ends. Just check it with WG. Nothing running. I'll still have a packet capture going, so UDP port 51820. Have that there. So now I'll start it again. WG quick 0. Sit there. I'll go over here. WG quick up W0. Bang. Oh fuck! You know what I did wrong? Look at this IPv4. That's no good. It's no good at all. I forgot something, because the endpoint was still that address there. So what I need is the IP6 address here, which is that one there. So endpoint and the port number 51820. All right, now this one's still running over here on the server side. It's still there listening. Okay, so get my packet capture, start that shit again. WG quick, up, WG0. Bang. Now, IPv6. Laughing. So on the client, if I just show IPv6 address, you'll see it's got the WireGuard address of 2 at the end, like I showed. There you keep. So if I ping it from this end, I can ping it. And same sort of thing before, it's just IPv6 now, simple as that. I want to test something really quickly. Now I just made that mistake before. For the endpoint, I'm just going to put that back to what it was. 51820. And start that up again. Because as you saw, I've got version 4 in the packet capture, and I can actually ping version 6 over an IPv4 VPN. That's pretty good. Fucking good. I've just discovered that just this second by making the mistake of not updating my endpoint to be v6. Now that was a pretty simple setup, just pinging one single host. But in the real world, you'd have hosts behind there. And where you had that allowed IPs, you just put a comma, then add the networks behind there that you want to connect to, and they'll go through and the routing table will be added. You can't just add their routing to your routing table, their networks, because the VPN itself has to know about them. That's pretty common with most VPNs that I've seen. So you add it to the VPN config and it'll add the routes for you when the link comes up. Now, as a lot of you have probably guessed, I manage a network. A friend of mine who runs a workshop, an actual workshop, not a soft skills workshop, one where there's cars and tools and shit. And what I do there is I send his camera video from there to here and record it here. So that's offsite for him. And I'll show you the difference between when I was running OpenVPN and WireGuard using the Raspberry Pi. It's just a Raspberry Pi 1 out there. So I'll just show you that on the SNMP graphs. All right, so this is the sort of thing I've got here. He's got his front camera, back camera, some other cameras, and that sort of thing. So I've got 4 video streams coming to me here. So over at his place, he's got a Raspberry Pi 1, and you can see if I just go back over a couple of weeks, this is the CPU load on that Raspberry Pi 1. So this is when I was running OpenVPN up here, and this is where I've got WireGuard running. So you can see the CPU usage went down a lot. Now at my end, I've got a Raspberry Pi 4 as my router, as you know. My processor didn't care much at all. So it was already pretty low for OpenVPN, but with WireGuard, with 4 video streams, it's really fuck all. Right, so here I've got my network and Scott's network. So mine is 192.168.1.0/24. Scott's is 192.168.103.0/24. So what I have is my router, right? And so my network's on this side of it. Scott's router isn't what I'm running the VPN on. So mine has WireGuard in here. Scott's doesn't. So he's just got a standard consumer router. So his network is on there. So within that network, he's got a Raspberry Pi, okay, which has obviously one of these addresses. So on that Raspberry Pi, we run WireGuard. So WireGuard in there talks to my WireGuard in here. So just like any other client, it sends its traffic out there and instigates the connection to me here. And then once that connection's up, we've got connectivity. Now all these hosts on this network, you know, blah 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 dot, I don't know, 10 blah 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 dot 11, 12, whatever it is, they don't really know how to get to my network because their default gateway is through here. And this router doesn't really know anything. I can add a static route and then it might do ICMP redirects through the Raspberry Pi, but it's too complicated for that sort of thing. So what I do know is none of his hosts out here are going to start a connection to me, only the WireGuard one. So that's fine. The way I connect to these hosts in here is a little bit tricky, I suppose. What I have on the Raspberry Pi here is NF tables. So that when I start a connection from say 192.168.1.3, if I want to connect to something over here like .202, so 192.168.103.202, what I do is I send that to my router. My router knows that this network, this 103.0 network's on there because WireGuard set it up. So my traffic will go down here through that tunnel, pop out at the Raspberry Pi, and then these NFT rules say do IP masquerading, just kind of like when normal home users go out to the internet. So I can then connect to any of these hosts and they'll see the connection coming from this Raspberry Pi's address on his network. And then the return traffic just comes back to me there. So none of these clients on his normal network really have a route to get to me, but they don't need to because I'm doing source NATing here at the Raspberry Pi on the way out as it pops out of there. So that's how I've got the setup. So my config on the router compared to his config looks like this. Now I've still got v6 going over here for something else I did, but just ignore that. My address on the router 3.254 and the address on his endpoint 3.1. So he allows at his end 3.254, which is mine, and I allow his at his end. But I also have his destination network here. So on my router, it adds this route to his network to say go down the tunnel, and he connects to me and all works good. And it means I can record stuff because he's got this motion camera out the back, and it just sends him a still shot, but it doesn't save video. So what I've got is recording, so we can see things like this. And what we found out, we said, who the hell is this just after 1 o'clock in the morning? And it turns out she was grabbing that little stool from there to go dumpster diving, because that's where they found the stool the next morning. Anyway, you can do that because we've got a VPN. Okay, so as I showed you, WG quick down brings up and down the link, but if you want it to happen automatically, just systemctl start WG quick at WG0. Okay, so that'll start it, and then enable it so it always starts WG0. Okay, so there it is, Wireguard. It was highly recommended to me, and now I highly recommend it to you. And as you saw, even making this video, I got the nice surprise of being able to put IPv6 down the IPv4 tunnel. So that's cool. Anyway, that'll do for now. Till next time, take it easy.